We're going to make this part two. Part two. Didn't have the mic on the first time. So lesson 65, radicals and trigonometric equations. You see our first question here. We're just going to go ahead and show right on over to this page. You're going to write down your equation. The first thing you want to do is you want to isolate the square root. So we added it to the other side, and then we squared both sides. So what we should get from that is cosine squared x equals 1 minus 3 cosine squared x. Okay, now we can bring everything back together by adding it or subtracting it across to the other side. So if I've got cosine squared x, I'm going to add that 3 cosine squared x. So that should give me 4 cosine squared x. Does that make sense? All right, so we get 4 cosine squared x minus 1 equals 0. Okay? All right. Now we begin the process of moving things and actually trying to solve for x. Okay? So in that process, we're going to add 1 and divide by 4. Okay, so we get cosine squared x equals 1/4. Okay, does that make sense? Yes? No? Kind of? Let's see if I've got... Okay. They do something kind of weird with this. They actually divide the whole thing by 4 so that you end up instead with cosine squared x minus 1/4. Because 4 divided by 4 is going to be 1. Okay. They divided the whole thing by 4. Okay? Equals 0. Because, and it's not to say that there's probably not a better way to do this, even by adding 1/4 to the other side and getting cosine squared. In fact, I am tempted to just go ahead and try doing it the normal way instead of doing it that way. Because this is cosine squared x, what I would do with this, and again, maybe I'm wrong, maybe I won't get the right answer out of it, but I would square root both sides. Okay? So that I'm getting cosine x equals the square root of 1 over the square root of 4. Right? I'm going to get what? I'm going to get 1 over 2. Right? Because the square root of 1 is 1, square root of 2 is 2. Okay? All right. But because we square rooted both sides, right? Well, at least I square rooted this and all of this, right? I should get positive or negative 1/2. Because whenever I square root the left-hand side and square root the right-hand side, I've got an option there. So cosine x equals positive or negative 1/2. Okay? At this point, what we need is we need to look at this scenario because what we're looking for is the degrees out of it. So adjacent is 1. Okay? So 1 with a hypotenuse of 2, which means we're at radical 3 here, correct? All right, so we should be at 60. But we also need the negative 1. Okay? Let's see. For whatever reason, they don't do the negative. So, but even on this positive one, we would get this one here as well, right, at 60. So their answers here are 60 and 300 degrees. Here she is. All right, so our answers are 60 and 300 degrees. I don't know why they don't end up using the negative 1/2, although negative 1/2 should be part of it. But 60 and 300 are the degrees that they get. What's what? My next class? My next class is geometry. Why? Should leave it on the board. Yeah, just to freak them out. Tell them that's what we're going to be doing today. Yeah. Is this doable? Do you guys understand what we did? Yeah, I think that this makes way more sense than to divide everything by 1/4, or divide everything by 4 is to just, and we ended up in the same position that they did. So I think this would make a lot more sense. Okay. All right. Funny thing about setting these things up is sometimes you wind up in some funny places. Oh, I think, well, no. You'll notice that 2 is the exact same question. So let's do it again. No. All right. When we get to 3, it says we want to graph y equals log base 3x. Okay. So if you, I mean, we're going to go into our y portion of our graphing calculator, so our y equals. Now, if you have a newer calculator, you can do your log base, right? So you know how to get math, go down to log base, and you can type in the 3x. What do I do if I don't have log base as an option? Log x divided by log 3. Okay, we're going to find the graph that's going to fit that. Okay, and that's what I'm going to have to do. Log x divided by log 3 graph. Okay, so we get something that looks like that. Okay, so we know how to graph logs now. All right, go ahead and graph number 4, log base 4x. Tell me what you get. You should get C as an answer when you get that in. All right, so everybody, you got your graphing calculator, Marcus? Okay, you might want to not be too lazy to get it and go ahead and do that. All right, so far we're pretty good on this stuff. All right, 5 and 6. It's going to look very similar to the first one. Okay, and so just looking at it, you're probably not going to notice a difference between log base 3x and log base 4x. Okay. All right. All right, let's come down to question number 5 and 6. So this should move us over to 6. And the funny thing about Saxon math is that sometimes you go from stuff like the square roots of trigonomic equations and those types of things, clear back to early Algebra 2 stuff where you're solving a system of equations. Right? And that's what you see for number 5, solve the system. 6x plus 5y equals 5, 6x minus 4y equals 3. There's like 6 different ways to solve that question. You could set it up as a matrix. You could use Cramer's rule. You could solve through elimination, which is probably what I'm going to do in this case, because what do I need to do with these 2 equations? Just subtract. Right? If I subtract, my x's cancel out. Right? I've got 5 minus. Here's the only thing when you go to subtract is make sure that you apply both the negatives. So that's really 5y plus 4y. Right? So we're getting 9y, what equals 8. Right? So divide by 9. So y equals 8/9. At least that's what it looks like to me. Oh, I added the 8. Yeah, or added the 5. Yeah, we're subtracting. Never mind. My brain will get on board here in a second. 2. So 2/9? Yes. 2/9. Okay? Yeah, good catch. Yeah, I've got like 5 lines of work that's supposed to show up here, and it still gets into y equals 2/9. And you'll notice in here, all they're asking me to do is solve for y. Like I said, I don't know, you can't see this in the video, but I have like 10 lines of work here. And even in the end, I wrote ... put into a matrix. But even that, this is faster than that. So the more you get used to doing this stuff, the faster you are at it. Okay, so I'm not necessarily going to show you the book way of solving that. Actually, take a look at 66A and look how they want you to solve these. Does it look complicated? It's on page 422, 423. Does that look more complicated than what we just did?
Yeah.
Yeah, by a bit.
Why is that stupid?
It's not. It just sometimes it picks really weird ways for doing things. Now, obviously, like with number 6, solving through that form of elimination may not be the fastest way to do it.
Yeah, multiply.
You might have to multiply both equations to get a common x, and we do want to solve for y, so getting rid of x is our preferred method. So, let's see, we'd probably multiply all of this by 2, all of this by 3, right? Rewrite the equation. So get 6x minus 6y equals 8. Down here, get 6x plus 3y equals 6. Subtract, cancel out your x's. Negative 6 minus 3 should be what? Negative 9y. This time I'm going to subtract 8 and 6. What are you going to get? 2. 2. So y equals, lo and behold, what? Negative 2/9. They're not real creative with their problems and their answers there.
I think that's actually going to be the answer. I thought they were just putting that.
Yeah, there's no way, right? No way. Yeah, and it is. So, but that's still, you go back and you look at the Saxon book and like their method for explaining how to do that, way more complicated than just elimination. Okay? All right. All right, we may actually get through everything today. I don't know. Write the equation for the sine function that matches the graph below. All right. What does that graph look like? Does it look like a sine function or a cosine function? It looks like a cosine function, which means we're going to need a phase shift. All right, we're going to need a phase shift. But let's go ahead and label the things that we know we're going to need to find. We're going to need a center line. We know we're going to need our amplitude. We know we're going to need our function. We know we're going to need to check on the period. But it says the period is 2 pi, right? So am I going to have a period change? No, but I am going to have a phase shift. So I'm just going to leave it as the first p, okay? All right, so can anybody tell me what the center line of that function is? All right, so center line is 1. What is the amplitude from that center line?
2.
No, 1. Okay, so amplitude is 1. What function are we going to put this in? Sine, and what variable are they using? Sine x. So now we just have to figure out our phase shift. Okay, now hopefully, let's see if we go over this, phase shifts and period changes. They've already talked about this to a degree, and I don't know, hopefully I still kind of have a bookmark in this. In terms of sine phase shifts, I would go back to lesson 57 because they're going to do a better job of defining this. Page right around 375. Okay, so in a sine, you want to look for the closest place to the y-axis where our graph is going upward in a positive direction. Okay, so if I look at that here, that's actually, if I'm not wrong, right there. Right, you see what I'm talking about? It's coming up. Okay, in fact, it's going to cross our center line about. So it does have to cross the center line, but it crosses like right there. I know that's hard to see because the graph's not very good. Okay, but if we look at our points, this distance right here is representing 1 period. Does that make sense? All right, so I've got 1, 2, 3, 4, 5, 6. So I've got 6 notches that represent 360 degrees, correct? What's 360 divided by 6? 60 degrees. All right, so each one of those notches should represent 60 degrees. So, all right. And if it's coming up 2 notches back, it looks like that should be 120 degrees. So we'd want to convert, well, for whatever reason, it should just be 90 degrees. I believe where this is coming up, and it may just be hard to read, but I think it should be halfway between those 2 points. So it should be, what's the half distance between 60 and 120. 90 degrees. So what we see is that that point where it's coming across the center line going up is actually at negative 90 degrees. Does that make sense? So because it's negative 90, it's back to the left, we're actually going to write our phase shift as, let's see, in this case, x plus pi over 2. And you say, why pi over 2 instead of 90 degrees? Because they showed me my period as a radian, I have to put my phase shift in terms of radians. Okay, so you understand the pi over 2. You understand it's plus because it's negative. Okay, so now whenever we go to put this all together, our equation should look like this. Y equals, so we're going to start off with our center line, which is 1, plus our amplitude. Do I need to put 1? No. I don't need to put 1 because it's a coefficient to our function. So sine parentheses x plus pi over 2. Okay? Do we understand all the ingredients there? Okay? You take it one step at a time. You know, and that's why I leave a bookmark in my book so I can go back and review what exactly I'm looking for whenever I'm talking about phase shift. Let's do number 8. Okay, write the sine equation for this sinusoid. Notice that this one's a touch more difficult just simply because it's even offset. It doesn't even look like a cosine function, right? So we do still need to find our ingredients. We need to find our center line. Okay, let me look at this. Our center line in this one, so you're going to take your maximum, which they're typically going to give you those two numbers. Our maximum is 5, our minimum is negative 7. We need to find a center line based upon that. How do I do that? Add them and divide by 2. Find the average. What's 5 plus negative 7? Negative 2. What's negative 2 divided by 2? So my center line is negative 1. All right, so if my center line is negative 1, let's see, in this case, what you have to remember is that what we're saying is that our center line is at negative 1, so my center line is coming across a little below, you know, say something like this. So as a sine function, again, we're looking for the closest place where this is going to be crossing. In this case, it should be, that's tough. In this case, we're going to call it a negative amplitude. And so if we're going from negative 1 down to negative 7, we have an amplitude of negative 6. Okay? Okay? Our function is sine x. Okay? Let's see if we have a period change in here. It doesn't, let's see. It doesn't look like it. It's pretty tough because what we have to do, let's erase this here for a second. Let's see, a pi over 2, 3 pi, because we're shifted to about there. Here's 90 degrees. So if our notches each represent 90, we'd be at 180.
3 times 180 is...
Okay, let's figure out what that 3 pi over.
270.
90, 180, 270, 360 then, right?
Yeah.
Yeah, so it's pretty, it doesn't look like there's a period change in there. So we're going to ignore period change, and we're just going to talk about phase shift. Okay? Okay. So that's what's difficult about these, is because it's hard to get that negative 1 in there and see where it's crossing. Okay, on our sign change, I'm going to go back to lesson 57. Okay. Yeah, I don't like these just because whenever you start looking at your book, like, let's see, like in lesson 66, you're going to see all through like the examples in this lesson are going to give you degrees, or they're going to be very specific about where things are crossing at. So like for instance, like problem 8 and 9, you're going to be able to see that stuff really clearly as opposed to these where it's really not very clear. So I'm going to give you the phase shift on this one, and it should be x plus pi over 3. So it should cross at 60 degrees. Okay, which is going to end up probably like right around in there. So your final form of this is going to be y equals -1 minus 6 sine x plus pi over 3. Okay? Any questions so far? What's for lunch? I have no idea. Sack lunch? I won't complain because this is being recorded. It could be used against me. Okay. All right, 9. 9 would be our last question. Again, they want it as a sine function, or write the equation of the sinusoid. Okay. Notice that all our options down here are cosine functions, so we're going to have to write this, the shift and everything based upon the rules of a cosine phase shift. So 4 plus -10 should be what? -6. -6 divided by 2 means I've got a center line of -3. Okay. Let's see, my amplitude from -3 to 4 should be 7. Let's see, my function is cosine x. This looks like it has pretty much the same setup as the last one, so it doesn't look like they're applying any kind of period change. So we're just looking at phase shift. Again, they don't do a great job of, once we have a center line, of being able to determine where it's going to cross that at. But with cosine functions, what you're looking for is the maximum. So what we're looking for is where does this cross at? So, really it looks like it's going to be halfway between 0 and pi over 2. Pi over 2 is 90. So it should be 45 degrees, right? As such, that should be pi over 4, right? Does that make sense? So what we should write, and because that's to the right of it, we're going to write that as x minus pi over 4, right? And this one does the best job of really kind of making sense. So we should get y equals -3 plus 7 cosine x minus pi over 4. Right? Do we have anything that looks like that? Mm-hmm.
That is letter
B? D. D minus, not plus. Okay. Should get D for that. Okay. All right. We got done in time. So you guys have your homework assignment then.
tomorrow? No,
Homework.